because there's a lot of different, what I would call proof of work concepts now.
Oh yeah, definitely. And they're all, and it's a whole budding sector. Hey everyone, how's it going? So today I am joined by Yeti, and he has a lot to talk about when it comes to Dynex's updates to their Dynex Solve algorithm, adding in machine learning. And there's a lot of material to go over, so we're going to start off right with him.
I say it's been a busy week, shall we say. So for those who don't know, we opened up a Dynex mining pool recently. Obviously, that has gone through some major changes, as can be shown on there.
Yep.
It's recently gone through a lot of changes with adding the new machine learning aspect of to the Dynex solution. So whereas previously they were running only SAT solvers, now they've added quite a considerable amount of different choice for machine learning. And they've asked us to showcase a few examples, which we can obviously, we've got the video clips to show. We'll go through a little bit of it and also show you the new PoUW dashboard that can obviously show you the current status.
You actually just put the finishing touches on that, because that's your own design. Today, at like an hour before we start recording this, you just finished it and put it up live.
Yeah, it's been a bit of a task to get it out quickly, because once I showed Dynex what we were up to, they were very keen on us getting it patched up, ready for this video in general.
And not to toot Deepminerz horn too much, but we're the only pool in the whole Dynex that gives you this much information. You used to get some of this information off their old website. They redesigned their website probably about, what, a month ago or so. Some of that information is in there, but the page that Yeti put together on Deepminerz for all of the proof of useful work information is so much more comprehensive. You get a ton more information, and of course, he integrated the new machine learning. Some people might have seen on the old website too a bunch of ML jobs for beta testing. The beta testing's pretty much over. It's wrapping up here soon, but now it'll expand even more. You can get more information of what people are working on during this beta testing period.
Yeah, exactly. I mean, the beta testing phase from SAT solving, I would guess they're at that point where they're comfortable with the SAT solvers now. It's just how far can they push the machine learning is, I guess, where they're now at. Is that's why the beta testing program is about to open up fully. Link will be in the description for how to sign up for Dynex beta as well, if anyone's interested, as well as the SDK documentation. And yeah, I mean, I'm going to be on the first batch of beta testers, and I'm quite looking forward to it, because from a personal perspective, right, for my business that I do for everyday business, this could be really a perfect way for us to really cut our costs down. We spend a lot of money each year on our servers. If we can take away even the need for one server to have to sit there doing statistical data, then if it's half the price, it's a no-brainer for us as a business. So this is why I'm very interested in it, and why I've got so into it and gone down the rabbit hole, so to speak.
Oh yeah, definitely can save some money. And to expand on the SDK that Dynex is doing, here is the link and the website for it that's going to be open here soon. It's dynexcoin.org/learn/Dynex-SDK. That will get you to their SDK information. If we scroll through here, you can see a beginner guide, advanced examples, Dynex SDK on GitHub. This will be available once the beta goes fully public. Now, once the beta is finished and we go full running on machine learning code, the SDK will be fully open source.
Correct. Yeah, we've even double checked with Dynex to make sure that is the correct statement, and yeah, it's going to be released after the the closed loop beta part, and when it comes out a little bit more public, then yeah, everything will be released.
Perfect. So we have a few examples we're going to go through here in 1 second for you. Let us get set up for it.
The first video here that we're going to show, right? Let me just make sure that it's on the right one. Yep. Okay. So this is the example for the EV charging station, right? The example gives you the problem formulation and all of the problems listed, right? Maximize distance between charge stations.
Okay.
How many charge stations they can do. The whole idea of this is you build it much like any other machine learning algorithm, right? You tell it a set of instructions and it will go off and do it. Now, the best bit is, by the looks of it, their Python packages are now ready. So you can just simply choose import Dynex as part of your Python package, and like that, straight away, Dynex SDKs, class files, examples, everything like that will just download.
Oh, people don't have to rework their data models at all.
No. They also obviously require, or at least this one required the ability to use Dmod and PicoPSU, both of which are de facto standard libraries for machine learning and quantum computing, which is pretty cool. And yeah, like I say, this is the first real, I guess, video of an example of Dynex proof of use will work being actually used, right? So like we've seen the jobs come in, but we actually haven't seen somebody physically click that button, have we?
No.
So this is pretty cool.
That's what this is going to show, isn't it?
Yeah. So this is basically a minute-long clip. I'm pretty sure that over the next few weeks, you'll be seeing many more longer-based videos starting to come out showcasing what proof of use work can do, especially given the moment they let the beta testers go loose. There's going to be a lot of jobs getting pushed through that system, and it might get very complex solutions and jobs going in there to just push the system. That's the whole idea of that, beta program actually running.
Oh yeah, so, hammer it. That's so we make sure all bugs are out before it goes full on.
That's the biggest and important thing right now for Dynex is to now they've built the technology. Now it's time to validate that technology in order to make sure that if they need to bring refinements, they can bring them pretty quickly, and preferably before they come out of beta, because obviously it's easier to deal with software while it's in beta than when it's out there in the wild.
Well, what else? What is also great is they're using these standard settings and setup for machine learning. They're not reinventing the wheel; they're just optimizing it.
Yeah, and adding their own parts to it. So effectively, when you hit process, instead of it going off to a gigantic supercomputer, it's trickling away over to Dynex, who then put it on their decentralized supercomputer, and then it returns a set of variables.
Cool.
So it's very interesting, and yeah, let's take a look at it. So again, this is the implementation, right? So this is like your Python code. This is your importing of your base packages and some defined up scenario variables, right? So this is how you set the criteria of the job.
Okay.
So you can see here, this is how it's outputting all the variables, right? So it's working POIs in the map, old charging stations on the current map, and then obviously it's trying to draw lines all over the map without you seeing this, of course, but it's trying to work out distances, and it'll be working those out at 10,000 a second, probably somewhere close to something like that, where it's just massive processing. Again, more setting of the parameters, and then this is it. Here we go. This is the bit that that most people would probably want to see. And this is it here, run on Dynex.
Run on Dynex.
So
okay.
we submit the model to the Dynex platform and specify what we want to read from 1,024 Dynex chips. Right now, we were talking before we came on that 1,024 chips is not many chips.
There's more chips in an 8-card rig of 3070s.
Yeah, and that's what really shocked me. I was quite shocked that I only took 1,024, to be fair to, and we'll show it on the dashboard in a moment just how quick just 1,024 worked.
And everyone who's watching,
who's
watching, this is in real time. This video when he pushes play.
Yes. Yeah, this is not sped up. This is not like some trick of the camera. We'll be able to show you it as well, locked in on the system in a minute. So here we go. So model converted to PoUW,
okay,
which is obviously a industry standard technology. Anyone who's done machine learning to a certain level will understand what that is.
Okay.
And yeah, you can see this is working in real time, going down the system until we hit the actual sampler. Now, the sampler is what takes all of those variables you've just programmed, sends it off to Dynex, and it's sitting there going, hello, I'm waiting for a return. Now, this is the bit that I had to double check because it finishes so quick, right, that I had to just double check to make sure that this wasn't sped up, and it's not. It's locked in on their job solution API, and it really does finish this quick.
Okay. There's play.
So this is it firing up all of the different things, right?
That was what, 10 seconds?
11 seconds.
Elapsed. 11 seconds. That's it.
Yeah. So in essence, it ran on, 1,024 chips for 2-second bursts, but then it loops until it finishes all of the equations, right? That's why you see this part here lapse 2 seconds, 2 seconds, 2 seconds.
Okay.
Right. And you can see it's just, this is the accumulation of it working. And then, bam. So this took 6 workers.
That's nothing.
With a total of 15,360 chips, or 1,024 chips per user.
That's not even a drop in a bucket for the network.
No, it really isn't. Which, like I say, is impressive. Very impressive. I wasn't quite expecting to have this drop on our doorstep this morning, to say the least. But this is now this has given me even more questions, because now I want to know when I can get access to this, because I want to have a play. But the speed is impressive, right? Considering that we're talking that it's not a supercomputer that's connected by physical cables here. We're not talking about like something that's had, $5 million spent on it in infrastructure to put this tiny thing in a building, right? We're talking about a miner in one country and a miner in a different country. And yet it's able to understand the fact that there's a distance between and still manage to work together to do the job.
And it doesn't slow it down at all either, even with the latency going through the internet. No. Not
by the looks of it. Maybe this one here that says runtime 5 seconds here.
Yeah.
Or sorry, not 5 seconds, 5 milliseconds. My apologies. That's actually 1 dot over.
Oops.
So yeah, so this is just awesome to see. Like it from going from proof of concept to alpha to now just before a beta test. It's good to see the progress. And you can see, let's just play this on a little bit more.
Yeah, it should have the result down here somewhere, isn't it?
Yeah, you can see it's now populated all the data here, and it's basically sprinting out all the data to you. And there you go, new EV charger locations.
Nice.
And obviously that would be, you know, a very small parking area, right? For example, or it could be a relatively big town or city. The distance here is more just the confines of what you draw. Yeah. So if these two represent, say, parking, then it's just relative. It's not drawn on a specific map per se.
It works with whatever variables you give it to it. Yeah.
Correct. I would guess that down the road, as long as you program it, you could literally have things plot directly onto a Google map if you really, you know, was wanting to do that level of automation. Just go, okay, pipe it out to Google API, and then up pops a Google map with all the little pins on it. You know, cool. So I it's as flexible as you code it, basically. And I made some notes so that obviously we can obviously talk about it. So 15 seconds. All right, we're talking about, this is all your parameters, right?
Okay.
So this is all to do with quadratic models and how they're going to work on the Dynex network for computing wise, right? So some of this, like I say, is still much over my head, and I'm learning.
It's way over my head.
It's a rabbit hole, that's for sure. But it's interesting. Like, it's the next evolution of some computing models, and I don't mean Dynex as a whole. I mean quantum computing here, right? Quantum computing is the next potential iteration. We don't know if it will be the complete be all and end all, because we just don't know, but it could be the very next model. And that's why I'm interested in learning and understanding it now, so that I don't get left behind when it does happen.
Yeah, definitely.
So, you know, let's just keep going through my notes a moment.
Yep.
So 24 seconds, which is where we were talking about how they push the sample set to Dynex itself. And you can see here where it's sending all the quadratic models and everything like that. This is, like I say, it's
yeah,
just
it says right there, we submit the model to the Dynex platform and specify that we want to read from 1024 Dynex chips after an annealing time of 100 integration steps.
And this is something I like as well about their SDKs at the moment, that from what they're showing is the tooltips around all the different steps, right? So if you get yourself stuck or it's having an issue, I'd like to hope that there's as much information on the rest of the system as it is like this, right? Because this would make life really easy for a lot of people to get the understanding. So it's really, really cool. Let's just keep going through. Where else we got to do? Here we go. 32 seconds. 32. There. So it's 38. Yeah, perfect. So yeah, you can even see here, this is really cool, right? You can even see the version number of the 10 miner that's actually running. So if you notice, there's an older version of 10 miner running on that when that was run. It says OZM 120 instead of 121.
Yep. Okay. Yeah. There's someone running an older version. Yeah.
Yeah. Obviously, the energy used, that's going to be something that I would like to get more information on as well, because that would be quite cool to be able to chart stuff like energy savings, perhaps. I think that's probably where that could come in, because you would know what an energy cost is if you were doing it on a server, because you just take the time that you're renting that server and that's your energy cost, right? Because you don't pay for the energy of a rented server, you pay for the rented server, but technically that's the energy, isn't it?
It's included with the price, yeah.
Yeah, so you could probably have a formula to work out what your actual total saving would be as well, which to any businessman, that's always a good thing. Saving money is you know how you make good money over the course of a year. Yep, there's 42 seconds. This is the bit where it's obviously running.
And it's waiting to get the information back.
Yeah, and then 44, it should say complete. Yep, there we go. So all requested computations have been finished, and you can see that all miners of their status has stopped. Yep. And that would, on the miner side, is when you would see your job switch again.
I switch to another job.
And it switches back to another job. So that's pretty cool to see the other side of that equation now, because we've been so used to seeing this job number randomly appear, then it disappears, and then you're back to your normal job again. So yeah, that's interesting to see the other side of the equation now. Here we go. 55 seconds. One more, and then we're done with this one. So 55 seconds. This is perfect. This is the bit that I was interested in.
Okay.
So the existing charging stations are red dots.
Yes.
Right. The P are points of interest. So that could be any number of things. And then Dynex has computed the optimal placement of additional 2 charging stations, the blue dots, given the existing locations of everything else, right? Yeah, it's pretty cool.
Now, of course, without us knowing all the variables in this, that was at the very top, and actually opening it up, we can't tell exactly what's going on, but it computed all that within 10 seconds.
Yeah, I mean, these are some of the examples that are included in the SDK platform. So people will be able to manipulate these, play around with them, see what would happen if you changed some locations, right? If you change location by 1 inch, will it make a huge difference? If you change it by a foot, will it make a difference? You know, that kind of thing. And it's super interesting. Super interesting.
So it's included with SDK. Yeah, people can play with it.
Yeah, there's some example stuff in the SDK, which is really cool. That'll get people started who might not be too familiar with the code, like myself. Like, there's some bits that I'm familiar with, but there's also a hell of a lot that I'm not. Like, there's a lot to learn.
Well, you're the coder. I'm just a miner. Okay, so our second example here is a data set for detecting breast cancer.
I believe they posted about it in their Twitter feed about how they were able to do some new type of screening for breast cancer, which, like, that's pretty big. Like, that could potentially, you know, save lives if they can use their model to adapt it to learn and understand whether or not somebody has breast cancer earlier than possibly the standard tests. I think that's a great idea.
Absolutely.
So, let's have a look and see what it comes out like.
I see this one's doing a deep neural network.
Yeah, so this is basically a slightly different type of machine learning. Look, you can see how it's giving you I would guess this is, so this is neural activity functionality, and this is how it's going to plot all of the X and Y graphs and everything you're programming it to do, basically.
Okay.
And you can see this is the data preparation part where you're telling it how many data points to load. It's gone a little bit quick. Just that back a bit. So you can see this is just optimization of different methodologies, adding in the different machine learning understanding, right? So that Dynex's system is able to understand what you're actually asking of it. For it to understand to do one thing, it might need a package from something else, and then it'll be able to do that. So, but yeah, like, you can see that Dynex is going down this route of trying to give you the coders, right, the developers of the world, the means to build on their platform. And this is a great first step towards that.
Considering you're annotating everything?
Annotating, yeah.
Yeah, it's going to make it a lot easier for people who already are playing with machine learning to get into this ecosystem, instead of just, here's the SDK, try to learn it yourself.
I can actually see Retro Mike being one of the first to really push something on this. Just as a random test, just go, here's some massive variables, click go.
That'd be interesting.
Yeah. So here you go. Look, using Dynex Scikit plugin to reduce the number of features. It says here we can run a quantum algorithm for feature selection to find relevant features of the breast cancer dataset. This is being done by calling the Dynex Scikit Learn plugin, and again using quadratic models and such. So this is just again the same. It's the same logic as the previous one, just it's a different model set, right? So each job is going to have a model set around it that basically it's like a container that says do this, and this, and then give me an output.
Yeah, it tells it what to do with the data.
Yeah, in a nutshell. And I think actually that even DJ Mines will be doing a video a bit more on this, and I think we might even be able to get him to have a look and see what he's got access to if he's able to run some actual calculations. You see here again, let me just wind that back a touch. Sorry, I missed it. There we go. So that was 2048 chips per worker.
Yes.
It finished in 5 seconds. So 3 workers. So yeah, that is quick. That is very quick. And again, obviously you can see down at the bottom here, right? Mallob job updated 3532. Right, hang on, there we go. 3532.
Okay.
Right? Now, to understand what the Mallob job is, that's the bit that does their proof of useful work, and that is the thing that we just put on our dashboard. So, if anyone wants to be able to validate a machine learning job has gone on their system, you can literally use our PoUW dashboard and be able to actually, see that job number in the list, and you'll be able to see it locked in as a start and an end time, number of chips, and everything like that.
Oh wow, it gives you a lot of information. We'll take a look at that dashboard in a few minutes.
Yeah. And this is more what it's outputting now. It's just, in a second you'll see it'll pop out an actual result. There you go. Accuracy of NM classifier. Accuracy of NS classifier on test set. Wow. Wow, that is just basically, is that 98% accurate? I would guess if that's 0.98, because 1 would be 100%, right?
Yes. Yeah, 100% would be 1. It's got that breast cancer data set accuracy of, what's that, NN classifier on training set 0.98.
And then the test. So the training set is obviously what teaches it. So that's 98% accurate. And then Dynex's own proof of useful work system came out at 97% accurate. So that's pretty good. That's pretty good accuracy. Like, I mean, it's still not 99%. And most places, like you see there, the training set is only at 98%, right?
Yeah.
So the fact that they're close to the training set for, the accuracy is pretty impressive.
Yeah, there's not that much deviation from the training set. No. Now, I'm not going to feign that I understand what that chart means, but it's spit it out, and hopefully that's the information you want.
I'm not a scientist or a doctor, so I don't understand what the results are. But if it's 97% accurate, that could potentially help doctors save lives. I'm still very much learning this myself, and going through this is quite an eye-opener to me of just how far they've already got, which is pretty impressive.
Hey, that'd be great if you could use a lot of machine learning for science, medical science, because it'll be like the next iteration of Boink and Folding at Home and everything else. If this could take on the reins and keep on going, that'd be great.
Yeah.
And speaking of which, the third example is something like that.
Yeah, this is the one that really caused some waves in like Twitter and stuff when they announced this. That they were going to go and have a go at RNA folding on the platform. This is quite heavy loads, I would say. RNA folding is something that's quite.
Oh, that's on an order of magnitude a lot more complex than the first two that they've done.
So let's go and have a look, because this is a 2-minute long video. So
this one's 2 minutes.
I suspect this is the one that realistically, this is the full blown proof of useful work.
Okay.
This one.
Oh, this uses everything of proof of useful work.
Oh yeah, look at the functions that they're using in this. This is crazy levels of understanding. Like I did math, but not like this.
No.
Right? This is much like the first one, where you're importing all your classes and your modules and everything like that. So again, you can see here, look, Dynex Demod, to help with the quantum sides, emulating quantum computing on the Dynex platform. So that's pretty cool.
Okay.
And then obviously these are all the different helper functions that are going to be inside of the machine learning to help the job be able to understand where it's at and what it's doing at any one time. Then it's, you can see here, this is way over my head.
Yeah, I'm not even going to feign to understand what this is.
I can understand some of the coding, but
it says something up there, returns class constrained quadratic model.
So this is building a quadratic model that then it's obviously using constraint, disallowing overlapping of substems.
Yeah, optimization model for RNA folding. So
you can see here, this is the data sets that it's using, right? So dataset /hiv.txt. So this is the big, huge data set of all the numbers, right?
Okay.
Which you can actually download from RNA VLab, which is right here. You can see here there's some files. That then gives you out the HIV file that then you can, if you really want to, throw it straight through Dynex and see the results yourself.
Okay.
And you can see here that there's a deprecation warning. Don't worry, they're working on that. Basically, they're in the process of upgrading some of their base packages so that they can bring those up to date. And then here we go, folding HIV on Dynex mainnet. So this is again doing the same thing where it's converting all the code ready to go onto the Dynex network. And then there's the sampler built. There's it uploading the job.
That's uploading the job to the malloc, right?
Yep. So that goes directly off to the malloc that then gets distributed to all the PoUW and then all your miners pick it up. So this takes a little bit longer than your other ones because this is quite an extensive data set.
Oh, well, yeah.
So here we go. Here is it running. So they're using, some big amount of chips.
Yeah. Still a small portion of the network, not even.
Oh, yeah. But you can see how once one finishes, it just takes it back away and then it'll grab another one out the list. And you see there, 11,000 chips being used there, 10,000 chips.
Oh, God, yeah.
And you can see they're on SRB Miner as well, rather than 1.0.
AMD cards.
Yep. And there we go.
Oh, there's our results.
Elapsed. Oh, no, not finished quite yet.
Oh, no, that's right. It's still green running.
You can see it here. That's actually increasing the number of chips being used as it needs to.
Okay. It's dynamic.
Yeah. Yeah. You can see the number of workers shooting up as it's obviously realizing it needs more resources because the model's starting to grow as it's learning. Right. So it's going to just go, I need some more. I need some more. I need some more resources and just keep going. And there you go. Now it's just stopped. Now it's going to complete the files and create the job set. Again, you can see the job number comes up out the malloc, so you can verify that.
Okay.
And then if you notice, let me just go back just a touch. So this is the building of the final output effectively. This is how you want it to be presented. Now, some people, they might want that as raw data, right? So they take it out of there, they can take it off to their own servers and do whatever they wish with it. Or you can have it just produce it right now.
And this will make it a human readable content at that point.
Exactly. So this is asking it to basically create a color map.
Okay.
And you'll see it in a second when they run it. it'll pop up and draw literally what you've asked for.
Oh, okay, cool.
Go. And there is HIV folded. Now, like, the understanding of what it's doing is way above my head. The fact that it's able to do that, though, so quick. Now, I looked up some other RNA folding, like, speeds and times that's, like, considered right up there in the industry.
Okay.
And they're not far away. And at times, they actually beat them. So, I think D-Wave. Is it D-Wave?
D-Wave is one of the quantum computers that are, like,
yes,
have to run almost at absolute zero.
So, yes, D-Wave did RNA folding.
Okay.
They did it on their service. And, yeah, like I say, they are pretty much head-to-head.
Now, that's just one D-Wave quantum computer, correct?
Correct.
So, we've used not even 0.01% of the Dynex network to do something that takes the D-Wave.
Entire supercomputer, yeah.
Yeah, entire supercomputer to do in the same time, but then we can run, what, 1,000, 2,000 more of this exact same job simultaneously.
Yeah, you could fold RNA 50 times on Dynex if you really wanted to and have it pull out each one back to back. It's, like I say, the understanding of what it's doing is a little bit over my head from an actual technical perspective, but the fact that they're able to do it and do it as fast as like D-Wave and some of the other quantum computing and supercomputer companies, it's very impressive.
It's probably
very impressive.
I'm guessing at this point, but it's probably cheaper than trying to get processing time on a quantum computer. There's only probably not even 100 quantum computers operational around the world yet, and
yeah.
Dynex can do like tons of it, like beyond.
It'll be interesting to see once the beta testers start and they start hammering the network. That's where we find out how much they can really do in one go, and I love that. And Dynex is ready for that.
Stress test.
You know, they want to understand it. They want to push the boundaries. Why? Because that's how you innovate new technology, is by being at the bleeding edge. And this is just a further example of what, in theory, Dynex is there for, right? Medical perspective is off the chart, right? Because how much do medical companies spend each year on accessing supercomputers to crunch?
That's got to be an astronomical
theoretical
number.
stuff. Yeah.
Pharmaceutical companies trying to develop new drugs, and they got to process tons of data sets for this type of stuff.
Correct. The other one could be things like what was it?
Traffic control.
Yeah, I mean, not so much maybe traffic control, but traffic prediction of where roads might become busy in the next 20 to 30 years, so they can pre-plan around expansion. They can leave areas untouched because they know that within 30 years they're going to need to develop it. That kind of very complex model schemes, companies pay a fortune for that kind of thing. This is all a positive step in the right direction.
Oh yeah, it's only the first step, but
yes.
And this is not proof of useful work for every concept out there, but what they do with compute is insane.
Yeah, that's the thing. Proof of useful work is a very all-encompassing term.
Yep.
Shall we rather call it proof of compute?
Oh, definitely.
Is maybe a better acronym for it. Really, it's proof of compute. And I think they're proving that you can do it on the blockchain, right? And that bodes well for anyone else trying to do something similar as well. If some other projects are doing something similar with their own stuff, then that would be great. That there's more than just one, because there's a lot of different what I would call proof of work concepts now.
Oh yeah, definitely. And they're all and it's a whole budding sector.
Oh, absolutely. It's a very brand new industry, right? Decentralized supercomputing, or even just decentralized, applications and services, right? On blockchains and stuff like that is just so new and out there that it's gonna take time, and just a bit of patience to get things right. And I think that it'll all come along, and there's room for more than one project.
Oh yeah,
There's
well,
definitely more room.
one project cannot solve every use case in the world.
No. Now, I mean, you could technically program, the Dynex system to do a good chunk of that, but there's still going to be things that even it will probably struggle with.
Oh yeah, it's not going to handle everything, but what it does, it does it really well.
Very much so. And I'm, like I say, I'm very much looking forward to the beta testing. I'm sure that I'll give you a good rundown of it once I get my access.
I was saying, you want to throw your own data at it and see what it does.
Yeah, I've got some big data sets to throw at it, and even Dynex are quite looking forward to my data sets being thrown at it, to be fair. They took a look at my data set the other day and were like, this is really going to be a good test. So we'll see. Now, the way it's going to churn through that data set is maybe not as heavy as some of these that we've seen today. It's definitely not going to be hard on the network like RNA folding. But there is a lot of data, and that's something that maybe, they haven't had a check with. Like, they've done data sets, but they're not monster data sets, right? So now we'll be able to give them some more information back, and that's good.
Yeah, like the HIV one is very complex, but there's not a lot of data for it to crunch there. It just works on. You're talking about a giant data set of simple numbers just to work and churn on.
Yeah. Yeah, and also with our data set, it's very dynamic data, so there are wild swings of numbers, right? So, but there's enough data there that we should be able to give it a good test run, a really good test run.
Cool.
So yeah, and like I say, I mean, I know that DJ Mines is probably going to be doing a bit of a video deep dive in it as well.
Oh, I can't wait to see what he pulls up for it.
Yep. That's going to be really interesting. I hope that maybe Dynex sit down with him and give him a more interactive version that he can actually trigger himself.
Oh, that'd be perfect.
Because it's one thing seeing it on a video, it's another one being able to press that button, right? It's like if you were sat in a rocket like HQ, would you not want to push that big red button?
Do it.
Come on, who wouldn't? Who wouldn't want to push the big red button? So I hope that as soon as it's available, there'll be an interactive model that we can have a play with, and yeah.
So now Yeti's got the Deepminerz pool dashboard page up on here, and we're going to show the new section that he added that was on the Twitter page for Dynex, which is Dynex jobs. Right down. Yep.
So basically, this is still very much a work in progress, and we're going to add more to it as the Dynex APIs mature a little bit more. Right, these APIs are fresh off the press, effectively. But this is a good start, right? This is the current state of affairs with proof of useful work on Dynex. So you can see here that this is the EV charge station job that we saw in that video clip.
Yeah, it even matches up to the job number. Yep.
And then you can see here that it says 1,024 chips. Now, obviously, we've seen that it can actually be more than 1,024 chips. So we're going to adapt that slightly. I'm just waiting for Dynex to add some more to it. But this is a very good first version, shall we say, an early prototype of it. And I'd like to think that very soon that there'll be even more on this, and as there is more, we'll continue to add to it.
Nice.
And I just love the fact that we can see it.
Yeah, exactly. And then you can see the job right next to it, RNA folding. That used 100,000 chips, and the start and has a start and end dates. Which honestly, for that one, that was a 2-minute job, roughly. Minute and a half job.
Yeah.
That's it.
And that's the really cool thing, that you can see the start and end. Like, that shows you just how quick some of their processing can be, especially if it's not a huge data set or a huge job to do. And you can also see the current ongoing job. That used to be job number 3. They've since changed it to 3042 just to go along with their numbering convention, because I think it was a little easier to go with their new numbering convention.
Just restructured, yeah.
Yeah.
But that is the old job 3 still being processed to this day.
Yeah.
And that is a giant data set.
Yes, it is. There is also a very large reward against it, though.
Oh, God. That's what, like, $20,000 in fiat right now, roughly, or something like that.
Yes, at current price.
Okay.
I mean, that is what you call a nice, lottery win, right? So the best way to think of it like this, and I've actually had some clarification of how the proof of useful work rewards are going to work. So SAT solving, right, will be a case of, think of that like a Dynex lottery ticket.
Okay.
If you hit this final solve, you gain the reward for it. The machine learning is, think of it like pool machine learning. Everyone that contributes will get a small, tiny percentage based on your contribution of the reward. Now, obviously, at the moment, with it beta testing going through the motions of making sure that it all works, obviously the rewards are 0 at the moment, which you can see is reflected there. But once they're doing actual processing for legitimate clients, that will come with rewards. Now, they have occasionally put rewards on there. Not recently. They've been very busy trying to get some of these case studies out so that they can show them off. But yeah, there has been a few jobs that have gone through the system and are actually given rewards. So, but the machine learning, everyone gets paid for.
Okay. Now I know for
just the person that hits.
Now I know in the SAT job, the 100,000, like for that job, the 100,000 Dynex, that goes bypasses the pool, and the MALUP knows the miner by their address who got it, and it gets paid directly to that person's wallet.
So proof of work gets put through the pools.
Yes.
Right? Proof of useful work is done on the MALOB, therefore you're registered on the MALOB as an address, and therefore it can actually pay you directly for the job. And so the proof of useful work is completely off pool.
Okay.
It's on chain, but it's off pools. It's done completely separate.
So am I correct in saying for the machine learning job, since that's a pooled resource for the reward, the MALB knows every worker that has participated in that project, and it will divvy it up correctly, and again, bypass the pool and just go to each individual person's wallet. Correct.
Which is great in some regards from a pool perspective, right? As a pool operator, trying to even consider how we were going to be able to distribute those rewards out from the block unlocker system was going to be tricky. So the fact that they're going to distribute the proof of useful work payments separately away from the pools, as it were, and directly to the miners is a lot better. It will also save on, even though I'm a pool operator, you're not going to get the pool fee that comes along when you're mining.
No, that's just direct. Yep. That's just one less headache that pool operators don't have to worry about.
Correct. And like I say, there's more to come out this year. I'm pretty certain of it.
Oh, well, this is just the first iteration of it.
Yeah. We wanted to show that Dynex is, busy, right? I've been very fortunate to be shown some bits and pieces of Dynex early on, and that gave us the ability to come up with a solution that not only worked for our pool, actually ended up, it's ended up being a little bit of a benefit to Dynex too. It's that now they have somewhere where they can send people to view this in a very easy format.
Yeah, and Deepminerz is the only pool that has this implementation at the current time. Yep, currently. Yep.
I suspect that other pools will integrate their own spin on it eventually.
Once they learn the code and everything, for it.
Yeah, once they get their head around the code, I suspect that other pools will probably go about trying to integrate with it.
And just so
So
everyone
yeah,
realizes, you don't have to be mining on Deepminerz to see this page. Anyone can view this page.
correct. Yeah, it's not locked behind a username and password or anything like that. It's freely open and available to view to anyone, whether you're mining or not.
So that's pretty much everything for this video. Basically an overview of what Dynex has been up to for the last month, the implementation that Yeti has put onto the pool himself, and hopefully DJ Mines will be coming out with a video in the next week or two, which is going to expand even more so on this video itself.
Yes. Yeah, I suspect DJ's video will be a little bit more in depth. It'll be a completely different perspective as well, given that DJ doesn't come from a coding background like myself, right? So, because if people from a non-coding background can pick it up, that opens doors massively, you know.
And I'm definitely not a coding, and I can't wrap my head around half this stuff. The one thing I love is the page you put up on the poll, because I missed having that from the old website, and this even gives you even more information. That does. It's always nice to know what you're working on.
Yes, yeah. Some, you know, it is after all called proof of useful work, right?
Yes.
Now there's the proof. People were concerned, shall we say, about Dynex. Well,
there you go.
The proof is in the pudding, as they say.
If you understand machine learning and stuff like that, download the SDK. Take a look at it.
Yeah, apply.
I'm not going to download it because I wouldn't know what to do with it.
Yeah, you can apply for the beta. We'll make sure that link again is in the description.
Yep.
So that they can apply for it. And if anyone's got any questions, jump into the Dynex Discord. They're super helpful.
Well, everyone, thanks for joining. Yeti and I will catch you on another video.